Phys- Physics chapter 28, theory video 5. We are going to discuss about line spectra. So now you know that when white light passes through a diffraction grating or through a prism, it will get dispersed. So this process, the dividing white light into its components, is called dispersion. And this is an example of a continuous spectrum. Continuous spectrum is, when it is broken down. Now the visible light, that the white light, has a range of wavelengths ranging from about 400 nanometers, that is the violet wavelength, to red 700 nanometers. So this is that gets dispersed to that. So that results in, you have discussed these things, these diffraction gratings. um, we have discussed in O levels as well. So this is going to be a continuous spectrum, visible spectrum is seen. So then, now, uh, when this light passes through hot or cold gas, it actually there are some changes that occur. Now, the gases such as neon or sodium, we will see that, about these light beams that makes up these marketing boards or whatever. So they are neon lights. So they have different colors. So neon or sodium, we will see only a certain color present. So this particular color has a unique wavelength. Uh, Now, if we use if the source is narrow, and if we use a diffraction grating, we will be able to see the line spectrum. Now, uh, now in when when you take the line spectrum uh, of hot gases like mercury, helium, and cadmium, we will be able to see a spectrum with a unique wavelengths. So that will be, these unique wavelengths would be observed as different colors. So then this is how people can identify what gases are most common in stars. Now these are the line spectra for uh, uh, mercury, helium, and cadmium. So you can see the difference. You can see the difference: mercury, helium, and cadmium. So as a result, using this phenomenon, we can actually find out what is available in it, what gases are available in these in the stars, etc. So without ever having visited a single star, we have only sent some probes towards the sun, but we have not sent anything beyond our solar system to reach a star. So how do we know that these stars are made up of what gases? Because we can carry out, we can test the light that reaches from those stars using mechanisms to divide that light or spread that light, uh, or to find its components, and as a result we will be able to see which gases are present. So the line spectra which shows the composition of light emitted by hot gases would be known as emission line spectra. Emission line spectra. So hot gases emit light. Uh, uh, so that results in something called the emission line spectra. Uh, then there is another kind of spectra known as absorption line spectra. When this happens, when white light passes through cool gases, when light, we can observe what happens after sending this white light through a diffraction grating. Then we will observe that white line spectrum white light spectrum would have black lines across this. So this is because different wavelengths would have been absorbed by the uh, from by the gas. So some wavelengths would be absorbed by the cool gas when it is passing through. So that is about the emission line, going beyond the emission line spectra into absorption line spectra. Now, usually the stars have very high cores, hot cores. The interior is very hot. However, when they come out, they pass through cooler outer layers or cooler atmospheres. So as a result, there would be certain wavelengths being absorbed. So now this is what happens when you observe the spectrum of the sun. So there are when the light coming from the hot interior comes out, it will be absorbed by the cooler atmosphere. So that is basically what you need to know, and you have to know what these things mean: absorption line spectra, emission line spectra, etc. So let's write down a note, then you would be able to understand it better. Write down line spectra. When white light passes through a prism or a diffraction grating, light can be split into its light can be split into its composition colors. This splitting of light into its components is known as dispersion. The visible light spectrum of white light has a range of wavelengths from 400 nanometers, which is violet, to about 700 nanometers, which is red. This is known as continuous spectrum. Please underline what continuous spectrum is. When hot gases such as mercury, helium, and cadmium emits light, they would have unique wavelengths. When observed through a diffraction grating, a line spectrum can be seen, which can be used to deduce what gases are present in stars, because it has a unique collection of wavelengths. These line spectra, which show the composition of light emitted by hot gases, are called emission line spectra. Next point, when white light passes through cool gases, and observed after passing through a diffraction grating, we will observe that continuous white light spectrum would have black lines across it. This is because certain wavelengths would be absorbed by the cool gas when passing through it. The resulting spectra is known as absorption line spectra. I hope you understand. We'll discuss the next topic in the next video.